Hi friends, this is the GATE 2012 2 marks question in the digital communication. Okay, in the optimum quantizer concept. It is very simple. Okay, first see the question. Consider a real variate source whose samples are independent and identical distributed random variables with the PDF function f of x is shown in figure, and consider the 1-bit quantizer that maps positive samples to value of alpha and others to values beta. And alpha star and beta star are the respective choices for alpha and beta that minimize the mean square quantization error. Then find the value of alpha star minus beta star. Here alpha star and beta star are which is minimize the mean square quantization, means these values of old quantization levels which is minimize the quantization error, means these are optimum values. And here, so from the concept of optimum quantizer, the optimum quantization levels are at the centroid of the quantization region. What is meant by centroid, my dear friends? Centroid is nothing but expectation of x in that region. So here alpha is mapping positive values. Here alpha is mapping positive values, means alpha is okay expectation value in the positive values, expectation of x in the positive region. Expectation of x in the positive region means x into f of x dx. This is nothing but expectation of x. This is nothing but expectation of x. Okay, for x is positive, x belongs to positive integer by okay integration 0 to infinite, it is f of x dx. Actually, there is a concept is called optimum quantizer. In this, if okay a and a plus 1 are the decision boundaries of a quantization region, and quantization is x cube is the ith quantization level, then x cube I equal to integration ai to ai plus 1 into x into f of x dx by integration ai to ai plus 1 into f of x dx. Actually, this is the concept. Actually, okay, for optimum quantizer which is minimize the mean square value. So this is the concept, that is the centroid. So I am using that concept here. So just here it is alpha is mapping positive value, that's why sorry alpha star, it is from 0 to infinite. And what is the beta star value is? So beta star is equal to, it is otherwise okay beta are the respective choices for other values, means negative values. Negative values means minus infinite to 0 x into f of x dx by integration 0 to infinite, sorry minus infinite to 0 f of x dx. Okay, now first of all okay we need the f of x function. Okay, the professor doesn't give the f of x and we have to find out. Okay, first of all assume that this height equals some k value, height equals some this k value, and we have a property, the total area under PDF function equal to 1. The total area under PDF function equal to 1. So what is this area, my dear friend? If the area of this okay this rectangular portion is k into 1, and the area of this triangle is 1 by 2 into height equal to k units and width equal to 2 units is equal to 1. What this is? Total area under. So this is the concept from the total area under probability density function equal to 1. And from this we will get simply the k value equal to 1 by 2. Okay, simply substitute here k equal to 1 by 2. Now I am writing the PDF function for positive values and negative values. What is the PDF function, my dear friends? F of x equal to, here from minus 2 to 0, that is negative values, the f of x is in the form of a ramp function. It is some straight line. So for a straight line, the equation equal to y equal to mx plus c. M is nothing but the slope. Here it is an increasing slope, so it is a positive. And what is the slope value, my dear friends? It is y2 minus y1 by x2 minus x1. And here we simply taken this is the k by 2 values. And what is the value of k? K equal to 1 by 2. So slope equal to k by 2 means k by 2 means k is 1 by 2. By 2 means 1 by 4 x. And where it is intercepting the y-axis, and k equal to 1 by 2. So that y equal to in the form of c here. This is mx, m is 1 by 4, and c value, y intercepting. What is the c value? Y interception value 1 by 2. From where to where? Negative value, minus 2 less than x less than 0. And next, the PDF function value equal to k, that means 1 by 2 when x is from 0 less than x less than 1. X less than 1. Okay, my dear friends. Now we have to, we derive the f of x function. Now we have to substitute this value here. Now we have to substitute this value here. Okay, what should be the alpha value? Okay, now I am calculating the alpha star value. Alpha star is nothing but integration 0 to infinite x into, okay, for positive values, what is the f of x value? K. K is nothing but how much, my dear friends? 1 by 2 dx. And this is nothing but the area of the PDF function, for positive. And what is the area of the PDF function? Of course, if k equal 1 by 2, this area value equal to how much, my dear friends? It is 1 by 2 is the height and width equal to 1. So this value equal to 1 by 2. This value equal to 1 by 2. So simply I am substituting this is 1 by 2. And moreover, I am changing these limits. Here actually 0 to infinite. But actually the PDF function is existing from 0 to 1 only. So that I am changing this limit from 0 to 1. From 0 to 1. And okay, what is the beta star value? Beta star value equal to, here for negative values, the PDF function exists from minus 2 to 0. So the limits are changing from minus 2 to 0. The limits are changing from minus 2 to 0. X into, what is the PDF function for negative values from minus 2 to 0? It is 1 by 4 into x plus 1 by 2 into dx by, and my dear friend, it is nothing but the end the curve of the PDF function for negative values. And what is the area of the function for negative values, my dear friends? You see that this is okay, this is 1 by 2 into, okay, oh, anyway, total area equal to 1 by 2. So already positive value area equal to 1 by 2 means this value is also how much, my dear friends? 1 by 2. So that the negative, the probability of the PDF function for negative values is how much, my dear friends? 1 by 2. So that minus infinite to 0 means actually from here it is minus 2 to 0. The value equal to how much? 1 by 2. This area, this value 1 by 2, this value is 1 by 2. Now we have to integrate, then we will get the answer. It is very simple. Okay, my dear friend. Okay. For alpha star, now, okay, alpha star value I am writing here. Actually, I don't have the space here. That's actually, okay, just I am writing this equation here. Okay, alpha star equal to, it is 1 by 2 into, it is 1 by 2 into, what is the integration value of x square by 2, where the limits are 0 to 1 by 1 by 2. And what is the beta star? The beta star equal to, it is 1 by, here, see here, x into 1 by 4 x, 1 by 4 into x square. 1 by 4 into x square means x square integration is nothing but x cube by 3, and the limits are from minus 2 to 0 plus, and here x into 1 by 2. X into 1 by 2 means 1 by 2x, and 1 by 2x integration is nothing but 1 by 2 into, it is x integration is nothing but x square by 2, and over the limits are from minus 2 to 0. Minus 2 to 0 by, and what is the value of this one? This is 1 by 2. 1 by 2. And this implies alpha star equal to, okay, my dear friends, this 1 by 2 should be cancelled out, and substitution of limits 1 by, okay, 1 whole square means 1 by 2 minus 0 whole square means 0. So alpha star equal to 1 by 2, and beta star equal to, here 1 by 4, and if you substitute 0 upper limits, it's 0 whole cube means 0, and minus of minus 2 means it is 8. So that it is 8 by, it is 24, 8 by 24, and plus it is 1 by 2 into, okay, okay, if you substitute 0, 0, then it is minus 2 whole square means, okay, anyway, 1 by 2, 1 by 2, it is 1 by 4. Okay, then the, if you substitute the values, you will get it is minus 4 by 1 by 2. Okay, my dear friend, okay, this is, sorry, here the value is not 24, 4 3 are 12, so it is 1 by, so this is 2 by 3 minus 1, so it is minus 1 by 3 by 2, so this is, you will get minus 2 by 3. Okay, the professor was asked that alpha star minus beta star. So this implies the alpha star minus beta star is equal to 1 by 2 minus of minus 2 by 3. 1 by 2 minus of minus 2 by 3. So if you take the value, this is LCM equal to 6, and 2 how many times? 3 times, and 3 how many times? 2, 4. So this is equal to 7 by 6. So the alpha star minus beta star value equal to, it is 7 by 6. Of course, if you find out, okay, from approximately 2 decimal values, so this is, suppose 2 decimals are 7 by 6 means 6 1 are 1, and 1 by 6 may, okay, 1 by 6 means it is again it is 1, okay, 1.1 means I mean 4, so it is 1.666 blah blah blah. So if you approximate it, this is 1.17 or like that. Okay, from for the 2 decimal values. So this should be the alpha star minus beta star value. Alpha star minus beta star value is 1.1666. So if the professor approximated to 2 decimal numbers, then 1.1 47 should be the answer. So this question was given from the optimum quantizer. Optimum quantizer means which minimize the mean square quantization error value. So very simple. So for optimum quantizer, the quantization levels are opted at the centroid in the quantization region. Centroid in the quantization region. So centroid is nothing but expectation of x, my difference. Centroid is nothing but expectation of x. So this is okay. I have written only this is for only numerator. Don't thought that the entire function, my friend. This is only I have written for only numerator. Expectation here x. Z plus means integer, positive integer value. Don't thought that what is this Z plus. All those things. It is very simple, my dear friends. And here this solution was given by some institute B, and the professor is saying that actually this question is very lengthy. It will take 20 minutes of time, and if those if I am the person who is writing the entrance, I will leave that question. This type of the comments, some people are what giving. The institute B is given, and still they solved the question and they are okay calculating some beta star equal some -10/9, and they are got a wrong answer. So actually the questions in the GATE exam is not lengthy. Actually they are very conceptual. You have to know the concepts. If you don't know the concepts and you are appearing for the exam, and if in the examination for minimum quantization error, what we have to do, we have to write down the quantization error expression, and we have to differentiate and make it, and we are taking the terms okay, swapping the terms, and okay, take the common terms, and it will take much more, it will take more time. So that we have to know the concept. Okay, some quantizer is there, optimum quantizer, which produces mean square quantization. So for mean square quantization, simply the quantization level is centroid. So if you have to know the concept, then the solving of the question, it won't take more than 1 or 2 minutes. So if you don't know the concept, then it will take 20 minutes. And that's why it is very important, my dear friends. That's why it is very important. You have to learn the subject in a conceptual manner, not in a formula orientation. And GATE is an entrance which is used to check your application skills. So you try to learn the concept, more concepts, rather than solving the same model of the questions repeatedly. You have to learn more number of concepts so that you can able to solve any question that will be given in the examination. So if you follow the optimum quantizer concept, then it won't take more than 1.5 minutes. Actually, to explain you, I have taken this much of the time. If you know the concept already, just you have to start it here, and just this is the integration. And if your integration is very fast, you can get the answer within 1 minute only. So the GATE questions are okay. I have been saying the GATE questions are not lengthy ones. Those GATE questions are some conceptual based one and some logic behind that. So we have to identify the concept behind the question. So if you are unable to identify the question, then it's a very tedious process, and that's why it is very important that you have to know the concept, my dear friends. I hope you enjoy my video. If you see that some of the professors say that I feel skip this question. Actually, I was shocked. How would you skip this question? It's a very simple question one. Okay. Thank you, friends.